Hello guys, welcome to another episode of Networking in the Cloud. I just want in this video, I'll be showing us some troubleshooting steps with VPC firewall and how you integrate it with your VPC, with your private subnet, with your NAT gateway, just a little bit of that. And most especially, I just want to show us, some little things to actually look out for when you're working with VPC firewall and you want to, set it up to protect your VPC. So that's basically what I just want to show us. I don't want to waste much of a time. So I picked up a diagram from the AWS public blog that is publicly available, of course. So this diagram is this one that I'll be showing us here. As you can see, this is not the whole thing that I've set up. It's good that you have AZA, AZB, AZC for redundancy and for failover. But just for the sake of this video, I'm just only going to do everything I've done is from this side up to the AZA. So the only thing I did is just for the AZA, and this is what I've set up in my environment just to show us. And you can see what I have an instance in a private subnet that has a default traffic to the NAT gateway. So the NAT gateway has its own subnet also. Although I don't have an ALB as part of the setup, maybe in another video I can decide to test that with test the firewall with ALB. But right now, what I have is a NAT gateway. So you can see that the NAT gateway also is in its own subnet, so it's separated, and this is good when you're trying to protect different subnets. So the NAT gateway will get the traffic and we send it in its route table, as you can see, and send it to the VPC endpoint, which is the same endpoint, which is the endpoint that we're using for the firewall. I want to believe it's the same endpoint for the gateway load balancer. So from here, we can see that the firewall endpoint itself also has its own subnet, which we can see here in the diagram 3.0, and that is pointing to an IGW here. So from there, we take it up. The IGW also has its own, route table. It has its own separate route table, and that comes in very handy when with the edge association, which I'll explain later on. So yeah, so let's just jump into what I have in my environment, and I'll just show us what I've set up so far. So maybe in case any one of you is trying to do the same thing, you can just see how I've set things up, and I'll show us how it works and the simple rules that I actually put into the firewall. Just a simple rule. You can test every other rules, and you can see that that rule is actually working, because if I block the traffic, it's going to show. If I allow the traffic, it's also going to give the output of what's going on. And okay, so let's just jump without wasting much of our time. And that's the reason why I actually set it up already in my environment, because if I should go ahead and be setting it up while you guys watch it, this should be a lot of time to spend. So currently you can see this is my VPC firewall. I have the networking in cloud firewall, and I also, if I scroll down, I have a policy which I call G policy, and it's associated with the VPC. And I only create I created it in this subnet. Yes, it's in this subnet, and you can see the firewall endpoint is in AZA. For availability's sake, for highly available sake and redundancy, it's advisable that you create it in multiple subnets, so that it can also, in case you want to, you have a workload that is spread. But for the purpose of this video, I'm only doing one AZ. In other instance, in a production environment, you should do more than one AZ, probably in another AZ that is one B, so that you can also protect resources or workloads that are there. And you can see I have endpoint ID for this AZ. If I should have another AZ, I'm going to have another endpoint ID in that AZ. and you can see that the status is saying that it's ready to go. So let's just take it from the start, from the scratch, from where I showed us on the workload instance, what I did. So here is my instance. Our focus is on this private sub instance, private instance. The public instance is running because I'm using it as a jump box into this private instance. So as you can see from there, we're going to look at the private instance subnet. And this is the subnet. The subnet is spoke sub prive 2. And this subnet also has its own route table. So you can see every subnet has its own route table to, properly decoupled resources or workload. So if I jump to this route table, that can just show us, from this route table, we can see, let me just go to the subnet so I can show us that one also. So from the subnet, sorry, the whole thing is to refresh. So it's been a while that I jump on this side. So let's just wait a couple for it. So if you look at the subnet, this is spoke sub B. This is a subnet that I have my instance. Yeah, this is the subnet that I have my instance. This is the 4.0 subnet. As you can see, the subnet and its route table, we can see the route table. I have all zeros going to the NAT gateway. Yes, the NAT gateway. So what subnet is the NAT gateway in? I actually create the NAT gateway in this subnet here, which yes, I put the NAT gateway into this subnet, and that's why the NAT gateway will be having the IP address, the private IP address in this subnet. Please take note of this. I will come there again to explain that. Just take note that the subnet, just take note of the subnet for the NAT gateway. So what else again? Let's look at the route table. The route table, you can see, like I showed us in the diagram, the default route, because the instance is going to send all its traffic, internet traffic, to the NAT gateway. The NAT gateway picks it up and it forwards them to the firewall. Then the firewall checks the packet with the rules that has been configured. And what rules do I have? I only have, if I go to, let me see if I can look at it this way. Okay, so this is the rule I have. I have a stateful rule. The stateless default, I'm just leaving that for now. I just want to have the stateful rule. Maybe I don't want to compact everything into a single video. That might take a lot of time. So if you look at this rule, what do I have in the ICMP rule? As you can guess, it's an ICMP rule. So it's going to be like, okay, I'm permitting so IP, the source destination. I'm using the 5 tuple section of the firewall. We have the 5 tuple, we have the domain list, and we have one other one. So now this should actually show you what is going on. I have the source. I could put any here, any here, but I'm going to explain this later on just for test. And for the purpose, for the sake of that, let me just change that so that we can see, so I can show us I use custom, so I can put any there. Let's just save the rule. So it's an ICMP protocol. So yeah, that's it. So this is the rule that it's going to check against, because this rule is associated with a firewall endpoint. So it's going to check this rule and it's going to do whatever it needs to do with it. Many of you are very good with the firewall rules, and you can either use the main list, you can use different, well, it's just the same thing if you are a firewall person or a security person, you know what to do. So from that side, we go to where else are we going to go after the firewall? We send to the firewall, then we go to the firewall subnet. So what subnets are we using for the firewall? So if you look at it again, if you check this subnet that I showed us from the firewall, let me just go here. Yeah, so I showed us a subnet, the firewall details. It's going to show this subnet EC1E. So if we go here, we can see EC1E is the firewall subnet. That's why and that's good. That's a good thing that you actually you put names to everything, every resources that you create, so it makes it easy in troubleshooting. So the firewall subnet, this is what we have. We can see it's in 3.0, and the route table, what does this say? It says I'm sending everything to the internet gateway. Cool, fantastic. So now that we have the internet gateway, we have this in the route table. What else do we need? And we can see we have different route tables also, of course. And what else do we need to do? So can we just go ahead and test our traffic now? And this is route tables. So you can see different subnet also has their own route tables, and they are all associated with the subnets. You can see I explicitly associate them with it. So if I'm to test it, let me just see if I've not been logged out. So this is the private. If you want us to confirm this, we can just look at the instance and look at the IP address 1434. So that speaks right. So if you look at this, and what are we are just trying to do a ping to internet and see what's up with it. So I'm just going to do something. I'm just going to break it. I'll tell you what I broke so that it won't work, because this is a very important part that many people actually forget to do. So I'm just going to break it and the ping won't work. But just for argument's sake, let's do something. So we can see, as you can see, that the ping is working, right? So I'm just going to break something now. I'm going to pause the recording so I can break it. So then I'll try the ping again. It won't work. Then I'll tell you exactly what it is. So I've broke something in the lab, and I just want to show you. You know, initially you saw it working, and there's a part that I intentionally skipped not mentioning, so that by the time we are troubleshooting what could be the cause, you know, it will make sense. Because if I had shown you there, you wouldn't really see the need for that. And this is the part that many people actually miss. I'm sorry, I'm looking over this side because I have my second screen there, and that's where I'm really doing most of the work. So just bear with me. So if you can see, if we try to ping google.com, sorry about that. So you can see just hang there. Nothing is going, nothing is happening. It's just there. And what could be the problem? So let me just cut this. And if you look at, I explained right from the EC2 instance, how the private instance, I would send in all the traffic from the route table. I would send all the traffic to okay, this is the private instance, I believe this is the route. No, this one is actually, let me just, this one is public. This is the one that I have, you know, this is the one I'm testing, I'm using as a bastion host. So we can see from this side, I think this is the one, yeah. This is the one that, yeah, this is the one that has the private instance. It's sending its traffic to the NAT gateway. The NAT gateway is picking it up, and the NAT gateway is deployed in this path, and I can just change these to, let me just change it, you know, you just have to be able to give good description. Mine might not be as good as yours, but you know, this is just a lab purpose, but it's a good thing that you have the description so that you know where you're looking at. So this is just the route table that I'm using for the NAT's gateway subnet. So I have all the traffic going to the endpoint, the firewall endpoint. It gets to the endpoint. I've shown us what was in the endpoint. The firewall policy rule. I only have ICMP going from anywhere to anywhere, which is not good. You should be able to, you know, cut that down. And you know, VPC firewall is actually a kind of another layer for inspection and filtering of traffic. You know, NACO, the network ACL, and the security group does not really inspect. They just, you know, block, you know, deny and allow. But when you the VPC firewall gives you another level of security for the entire for your entire VPC. The security group only works at the ENI level of the instance or whatever resources that has an ENI, while the network ACL works at the subnet level. But the VPC firewall works at the VPC level. It actually protects your resources in the VPC, which is very good. So from these, we can see that it sends it to the endpoint, and let's go and check the firewall subnet itself. The firewall subnet says, okay, I received this traffic and I'm going to send it out to the internet gateway. Now, that's good. So that means that from all these things, the traffic, the ping that didn't work is actually going out to the internet. From the steps that I've taken you to, you see we're coming from the private instance, the traffic is going, it's sending it, there's nothing disturbing it. And just for your information, my security group and my network ACL for the instances are all open, so there's no issue with that. So, but from my explanation, you can see that the traffic is going from the instance. It went to the NAT gateway. From the NAT gateway, it goes to the, and as a matter of fact, so that you can see what I'm talking about, let's just do, come on, it takes you out to google.com. There you go. So you see, you might want to like, what's this IP before it starts breaking up? What's this IP address? This is my NAT gateway. So it shows that the traffic gets to the NAT gateway. And in case you don't believe me, let me just show you my NAT gateway IP address, 1.179. So that's the NAT gateway. And for many of you that saw the initial, I know you saw it, maybe if you didn't miss it, the firewall rule, that was the IP that I put in the source. I'll explain that also. Many of you might have been getting some ideas as to why that is. So you see, I have this there. That means that the traffic is getting to the NAT gateway. So the traffic from the NAT gateway goes to the firewall subnet, which has IGW for the firewall subnet, so that you can follow up with me, which has an IGW, as a target to the destination of any for the internet traffic. So that means the traffic is actually sent out to the internet. But when the return traffic is coming back, that's where we have the IGW route table. Now you can see this has no subnet associated with it. As a matter of fact, this edge association is a good thing, because if you have a route table and you've explicitly like this associated a subnet to it, you cannot use it as a edge association again. You cannot, what I mean by edge association is this. Now look at my RGW route table. Look at the route. I have these routes which are the local, because this IGW actually it belongs to this VPC, and the VPC, I have two siders. One is this, one is that. So I cannot be more specific with my route. If I decide to choose a route like this, and if I already have a subnet associated and I want to have a route like this, it won't allow it. Will give me an error. So, and because I want to, maybe I have a particular subnet that I want to associate with, and at the same time I want to have a more specific, it will not allow. So that's why this edge association comes in handy. Now you can see, because I want to control every route that comes directly to my IGW. I associated that edge device, it's like your edge router, to this route table. Then I can be more specific as to where I want to go. So, many people, this is where the mistake actually comes in. This is where the error can come in. So many people thought, oh, because the instance that I'm sending traffic out from is 4.134. So the return traffic, when my traffic is coming back, it shouldn't go directly to that instance. Actually, it should just pass through the firewall, which is why we have the target as this, because the firewall is the one doing, the rule checking. The traffic is coming out from it. So the incoming traffic makes sense to go back to it to be inspected before it goes into your environment. So many people will just put this there. Now, this should work ordinarily if you don't have a NAT gateway or a NAT instance in place. If you're only just sending your traffic directly to the firewall to be inspected, there's no NAT gateway, then it should work. But because we have a NAT gateway, and from the trace route that you saw that the traffic actually gets to the NAT gateway, and the NAT gateway or NAT instance, they work like a proxy. That is, they terminate your connection and they use their own IP address as the new source. They mask it up, use it as a new source to send out the traffic. So when the return traffic gets back to them, they know, because they are the one doing the NAT translation, they know that I need to translate it back to the original source IP. So now this route table is saying that, oh, I need to pass it, but when the traffic is coming back, the destination in this sense is not in the 4 network subnet, is in the 1.0 network subnet. And that's why that ping there was actually breaking up. Make sense? Yes. So if I should go ahead and change this to 1.0, because the 1.0 is the subnet that the NAT gateway is launched in, it will work. And that's exactly what I just changed. That's where I broke it up. Because just to explain, many people miss this part. Instead of putting the subnet for the NAT gateway, they put the subnet of the instance, which is not going to work. And if I should go back and do this, let's just say I did that, and if I change this to 1, that will make a lot of sense. So we can then see, if I go back to my ping, this is working, and if I break this up and I do the trace route, you see we get to the NAT gateway. The NAT gateway gets the connection, terminates it, then use its 1.7 as a source, then it sends it out, and that's why we can get this. So you see that makes sense, right? And one thing I want to show us is that, so that you can be like, how do we even know that the firewall is actually working, and it's not just we want to be sure that the firewall is indeed working. And maybe the traffic is not just going via something else. So let's just play a little bit around with this. And that's why I put the source, initially when I changed it to any, so we can do something with it. And let's just drop it. Let me just drop it. Let me just drop the traffic so we can. So save the rule. This is just a simple, simple troubleshooting method just to show us. So if I do a ping, you see, the traffic is getting dropped. This is the only thing I just changed from here, and the traffic is not going anywhere. And that shows us that the traffic is actually passing through the VPC firewall, and it's been inspected, and it checks it. You are not allowed to go anywhere, so I'm dropping you. So, and that's exactly what we want to see. And how do you want to also see that the source traffic is actually, the firewall is actually receiving the source traffic as a NAT gateway. We can then go ahead, and if we edit this rule and we add another rule, and we choose ICMP, and we make the source custom, and we put the 192.168.1.179 /32, there's a host route, and we make it like this. So let's just add this rule, and let's take out this one. Okay, I think it just took a little while before you can see. Let's just put this one there so that we can see that the original source is actually that. And if I do ping again, it's working. So it's looking for that source IP to come in. That's it, guys. That's just everything I just want to show us. Please pop in some comments if you want to see more videos on any service, any features that is within the networking in the cloud, especially with AWS. Just let me know, and it will come right up. Thank you for your time, and please don't forget to also hit the notification button. Cheers.